In this tutorial, we'll begin looking at automation in Music SDP. We'll learn how to generate automation IDs for our modules and how to use automation IDs and parameter numbers in the Automator board. For this tutorial, I've loaded a pedal board with an easy file play and a pitch shift module. I'm using a guitar sample created with the help of a friend, guitarist Lauren Gurgiolo. Let's quickly listen to what this file sounds like unprocessed. Now I'll send the guitar file into the pitch shifter by setting the output-input pair to A1. I'll set the shifter to transpose the sound down one octave. Let's play that file again to hear the difference. I've set this parameter by hand, using the mouse to turn the dial down to -12 semitones down. We can play with that dial in real time to hear the signal move higher and lower, like this. In a performance setting, we may need to move that dial down, but we might not have the ability to execute the dial turn accurately, or we might just not be able to reach that knob during the performance. That's where automation comes into play. The term automation refers to any kind of message that changes a parameter automatically for the user. Music SDP provides a wealth of tools to automate module parameters. We have Automator boards, controller automation, and we can even create complex scores for the system to follow. In this video, we'll only be walking through the basics of automation, and we'll look at how to create automation in the Automator board. In order to send an automation message to a module, we first have to learn about automation IDs. Automation IDs are strings of letters and numbers created to help us identify and refer to each of our project modules. Each ID should be unique so that we don't accidentally send a single message to multiple locations. The automation ID can be found in the top right of the module on the pedal board, above the module window. When you load a module, a unique ID will be generated based on the module process. We can use this default ID, or we can use the text box to change the name to whatever we want. Something short and easy to remember will make it easier to use. I'll rename the first module to Sample 1, and I'll rename the second module to Shift 1. Now, when we save the board, the new IDs will be stored with the board. Automation IDs can be changed at any point. IDs are the first step to sending automation messages. Next, we have to decide which parameter we want to automate, and we need to find the corresponding parameter number. Notice that in the pitch shifter, each parameter is accompanied by a number. This is the number that we will use to refer to the parameter in our automation. Because of how busy the Easy File Play module is on the screen, the parameter IDs are tucked away in a separate window. We can find them by clicking View Routing List. Each module either includes the parameter number by the parameter name or in a separate window as in the Easy File Player. Once we know a module's automation ID and know what each parameter number refers to, we can begin to build automation messages for the module. We can make a new Automator board by clicking New Automator on the System board, or by clicking Add Automator in Boards on the menu bar. Each Automator board allows us to create up to 8 automation messages, which can be stored in presets and recalled when needed. Multiple Automator boards may be opened at once to allow us to create as many messages as we need for our project. Let's use this Automator board to control the shift value on our pitch shift module. We'll learn to use the Automator by creating our first automation message. Each row on the board is used to generate a unique message, and all columns should be considered to complete that message. Notice that the first column asks us to type in the module ID. This specifies which module we want to control with the message. If we want to send a message to our pitch shifter, we can type in the name Shift1 and hit Return or Enter. Remember that this is the name we chose as the unique automation ID for our pitch shift module. Next, We'll need to set the parameter number that we want to automate with the module. Since the shift value is parameter number 4, I'll set this column to 4. We'll need to set a start and end value next. If I want to shift the signal from an octave below to an octave above the original pitch, I can set the start value to -12 and the end value to +12. Keep in mind that each parameter will have its own set of minimum and maximum values, so you'll want to consider this when determining exactly what effect you'd like to produce. After setting start and end values, we need to determine a ramp time. The ramp time is how long it'll take to move from the beginning value to the end value. So if we set the ramp time to 10, the shifter will move from -12 to +12 over 10 seconds. We have 3 choices for automation mode. One-off will make the Automator move from the start to end value over the ramp time just once. Loop will cause the ramp to occur over and over again, jumping back to the start value once the end value has been reached. Finally, ping-pong will cause the parameter value to bounce back and forth between the start and end values, with movement in each direction happening over the determined ramp time. For this demo, let's set the mode to ping-pong. The final set of columns allow us to group automation messages together. We can set the message to be part of one of 8 groups. Since this is the only message we'll be sending, we can choose any of the groups. It doesn't really matter which. I'll set this to group 2. Next group allows us to use this message to trigger the start of another group, so we could select which group to trigger from here. This means that we can generate a chain reaction of automation messages if we'd like. The next wait value allows us to determine how many seconds to wait before the next group is triggered. Since we don't need to make a chain reaction of messages right now, I'll leave the next group and next wait values at 0. The loop stop toggle will allow us to stop a looping or ping-ponging automation message once it's begun. We don't need to do anything with that toggle right now. With everything set up, we're ready to send out our first automation message. Since we set this to group 2, we'll need to trigger, or set in motion, the second automation group. Notice that there are a bank of buttons in the bottom right of the automation board window, labeled with the numbers 1 through 8. These correspond with the 8 possible groups, and clicking one of these buttons will begin any automation that's been set to that group. Note that any number of messages can be set to a single group, and we can even set multiple boards worth of messages to these 8 groups, so you can trigger any number of messages at one time. Let's turn the guitar sample back on, then hit the group 2 trigger. If we watch the pitch shift module, we'll be able to see the dial turning back and forth, following the control settings we set up in the Automator board. We can also hear the effect of the pitch shifter on the audio file. It may seem like a lot of work to generate a single automation message, but with familiarity, this process will become quick and easy. We can save presets by selecting a preset box and shift-clicking on it. We can even save entire banks of presets to our project folder so that we can remember and return to all sorts of complex automation combination. Here's a demonstration of a set of automation messages going out to various modules. I'm sure you can come up with a more compelling use of automation. This is still a pretty basic example. That's all for this video. In the next video, we'll look at how we can use automation IDs and parameter numbers to set up your hardware controllers.